Everyone. How are you guys doing? Hi, Tim.
Hello, Juan.
Uh, yep. Hi. So, yeah, hi, hello, everyone. Today we are joined by Timo Freund from EnBW, which is one of the Germany's largest energy companies and a forerunner in applying autonomous drones for renewable energy operations. Timo has been closely involved in the EnBW's dog-based drone program for solar PV inspections, wherein his team is turning what used to be like a low-frequency, high-effort inspections into now a scalable data-driven process. And he will actually share today a practical operator's view of how autonomy actually works in the field, the constraints that they have had to navigate, and the lessons that they have learned from deploying the drone in a box systems at scale. So, Timo, it would be really great if you can give like a brief introduction about yourself as well. And just for everyone's overview, my name is Rohan, and I am the account executive handling the business development for the European region. And today we have Timo Fune, as we just discussed. Yeah, over to you, Timo. If you can just give a brief introduction about yourself
Thank
before
you,
we can start.
Rohan. So, as Rohan mentioned, hello from my side. I'm Timo Freund from EnBW. I'm technical specialist for PV modules, taking care about all our PV modules in Germany. And yeah, that's why we are jumping into this topic with the drones, with the drone dogs, and so on. And so I got the invite by a flight base for this webinar, and we thought this would be a good opportunity to just discuss and tell you about some of the behaviors we have here on field. Yeah.
That's wonderful, Timo. And thank you so much for joining in. Indeed, it's a great opportunity to delve deeper into how such operations are actually being done. And of course, it would be a very good opportunity for other people to also understand how to take references from this and kickstart their deployment processes. So, yeah, just for again context, EnBW is one of the Germany's largest energy companies operating not just PV plants, but also other types of energy generation processes. And today we won't just not be talking about drones in theory. We are all talking about how exactly EnBW is approaching these inspections and what problems are they trying to solve, and exactly through autonomy dog-based drone program that they have entered into this particular conversation. So yeah, let's start there, Timo. Let's discuss certain things on how you guys started and what was the first thing that came into your mind even to start this kind of process. So to take over with the next questions, let's say uh, over how exactly you guys started using drones in the first place, Timo. Of course, everyone would know all these energy companies, etc., still rely on the traditional methods for inspections. So, how did you first convince your internal teams to just use drones as of the first place? Would be really glad to know more from you on this.
Yeah. So I think the first step was, I think, 3-4 years ago, when I started at the EnBW as a condition monitoring guy, and just checked up, okay, what's to be done to inspect all our PV assets. So when we started, we just had a small portfolio of around, let's say, 150 megawatt. And in the last 4 years, we raised up a lot. So I think the ramp was very steep. We are now at 1 gigawatt. So it's really steep. And that's why we had to confront ourselves with the point that we have to take care with less people, a lot of more PV sites, a lot of more PV modules, especially because not only more sites, it's also larger sites which we had at the end. And that's why we started to think about how we can improve and digitize all the PV sites. And yeah, the former process was more with, okay, you have a commissioning, you send a consultant and he will make an inspection, you get an Excel sheet and then a PDF report with some funny numbers within a plan where you see, okay, this is the one, and here you have an issue, and then you have to check in the Excel sheet, okay, this is a string failure, or there's a hotspot or whatever, and then you have to send the maintenance teams there and have to tell them, okay, that's the right module, you have to change it. And we thought, okay, this is no proper approach anymore. We have to go more and more digitized. And so, yeah, the drone was the first point because it's much faster in the inspection than just walking around and taking images from the ground. And the another point is that the digitalization is due to GPS coordinates and overlapping and auto-mosaic. You're much faster in tracking all the failures, and you can digitize it and have everything, yeah, on a platform at the end to handle it. So that was the main approach. So it was not only the hardware which we are looking for, it was a combination of hardware and software to also making the ticketing and managing of all the maintenance teams and so on. Yeah, so that was the, I think, major impact that we said, okay, large portfolio now, not digitized, and we had to be much faster. Yeah, these 3 points.
Thank you so much, Timo. I think that's a very logical thing, exactly why other energy companies, not just in Europe, but around the world, are adopting the same technology, at least shifting away from a manual way of inspection to a drone based way of inspection. That's what we are seeing today. One thing is very logical, right? Like in case of every solar PV inspections, they only happen few times a year. And again, let's say for a particular site, that frequency even reduces. So if you compare to, let's say, a traditional way of inspection versus, let's not even talk about the automation, but just a drone based inspection. So what were some of the challenges that got actually accomplished just in this, you can say, transition from a manual way to a drone based way of inspection for solar PV sites?
Yeah, as I mentioned, the digitalization is the first one for sure. So this is the one point. Also the point of handling everything, so taking images, where to drop it, and so on. This is super difficult. You always get from different maintenance teams, you get a PDF per email, and then you have to drop it in a SharePoint or whatever, and you don't know who has access. This is really a major point where we had a lot of struggle. We still have struggle because we are still not at the point that all our maintenance teams are handling drones, are handling the software we are using for the managing of all the tickets and so on. So this is still an ongoing process. We have big company, as you mentioned. We have a lot of internal but also external maintenance teams, one of my major to-dos is to train all these people to managing, handling tickets and so on in a digitized way. So, yeah.
That's actually great, Timo, that you tried to figure out certain things internally and how to solve them, at least using the drone-based technology. Now, imagine that for the same thing, you are going even one step ahead, wherein you have started considering the real autonomy, wherein everything gets automated, all of these reports are generated, which used to take, let's say, 1 week or 2 weeks. And now every day you get these reports about progress monitoring or about a solar cell getting damaged. But while I also talk with a lot of other customers and a lot of other enterprises, most of them have actually highlighted this points that for solar PV inspections, using a dock based, you can say, technology is very inefficient, of course. I would like to actually come up to this place, like, first of all, what was the driving factor for you to shift away now from the drone technology, which is the normal way of inspections using drones, to a dock drone? And how did that help you, like, or in order to improve your whole processes of inspecting these bigger
Yeah.
areas or bigger?
We are still in this proof of concept for the dock drone. So it's not that all of our PV sites have docks now installed. That's to be mentioned in first instance. But the step to starting the proof of concepts for using dock drones was primarily so the size of the PV sites is getting larger, and the German weather conditions are, for example, not always homogeneous, difficult for the pilots to have a really clear sky days or even more clear sky days. If you make detailed inspections with 3 centimeter GSD, as the ISC norm says, then you probably need more hours or more pilots on field for doing this in parallel. And yeah, this is a lot of costs. And then additionally in Germany, especially, but I think it's in whole Europe, that you have curtailment by grid provider, by the trading department because of negative prices. And so you will send out the pilot. He has to drive, don't know, 2 hours on site, and then he's there. And yeah, it's sunny, but this system is shut down due to the curtailment, and then yeah, no inspection is possible. So just the visible one, but not the thermal one, and then it doesn't help. So yeah, the flexibility, I think, was one of the major points, because the first sites which will be curtailed are always the big ones. Yeah, because there you drop a lot in the grid, and also for pricing with the trading, it's always the first one which will be shut it down. And yeah, so we said, okay, for the larger ones, it definitely makes sense to place a drone to just be flexible. I'm in the office here. I'm sitting in Stuttgart, and I have sites, the biggest ones close to Berlin, and I don't want to drive there 6 hours and then see, okay, weather conditions are bad this week, or I have good conditions but curtailed. I can just sit here in the office, start, and if I see, okay, now the signal of the curtailment is there, system is shut it down, I can just stop and go on at the next day or in the afternoon when we have power again. So I think this was one of the major points where we said, okay, yeah, this will generate a lot of flexibility for us. Yeah. And then we have also other possibilities to do. So we can make it more often. So not only a yearly one, we can also make it half yearly, quarterly, maybe, or even more often. Or we can say, okay, we want to do maybe a fence inspection by the drone, and yeah, play around a little bit, check if plants are growing well, if we have to water the new planted trees around the solar site or whatever. Yeah. So you just have a much better view about the whole site, and not just maybe from a static camera or two, which are placed in the site, and you just see this area. You can probably check the whole area within a few minutes. Yeah.
That's interesting, Timo, to hear. And of course, one of the key differentiators that come in, it becomes very difficult. So weather is one of the major constraints that I have heard from a lot of people, and the terrain actually. So indeed, that's actually something why people are even considering. Of course, the other automations do kick in, but yeah, it depends from I think company to company about what KPIs they want to actually explore in terms of the digitization processes. I'm very curious actually to learn more about what's actually live today. So of course you shifted. There's a whole transition that happens inside a corporate. It takes time first of all to even convince your superiors. So it's very logical. It took a lot of time, as you said, 3 years, 4 years. It took you. Now you are in the POC stage, but of course you have your plans. But as of today, it would be really wonderful to know what's actually live and what's working, and what do you think will be the next step. So it would be
Mm.
really wonderful if you can give your thought on.
So what we have done is the step from consultant inspections of PV modules to full drone inspections, which will be done by ourselves or by pilots which we are hiring by ourselves. So this is the step we have done, I think, 2 years ago, and we have now a lot of let's say lots of steps between training people, making our maintenance teams also to pilots, so shifting from external pilots more to internal pilots because they are on site. They are normally also there when the weather conditions are good because they have to do measurements on the strings, on the inverters or whatever, and they can use this time and say, okay, I just have the drone in my truck and I will deploy it and she will do inspection in parallel, more or less, yeah, and then I can do all the other inspection parts afterwards. So this is the step which we are at the moment focusing on, so that we get more and more pilots by ourselves. And yeah, the next step would be that yeah, we are trying to deploy more of the drone docks, but first we have to show that it's beneficial. So yeah, our management will see, okay, is it worth it to invest in docks, in software, in yeah, training people to do BV loss flights, and so on. And yeah, that's why at the moment we are still at the POC stage. We have now 2 docks installed, or will be installed. The second one this spring. It's already bought and at one of the locations of the maintenance team. So if the weather conditions are not that snowy anymore, we will place it in a site, and we'll do also this year do their inspections with the drone dock. And yeah, what we have done is, so we started with the dock 1. I think it's 1.5 years ago, where we had just the old one, the big one with 150 kilo deployed at one site, and then saw, okay, just play around, and we saw, okay, it was not possible to inspect the whole site due to due to the terrain. Yeah, we had 80 meters of height difference within the terrain, and also some trees between the dock and the farthest away modules, and then we lost connection if we went down to an inspection level, so 25 meters. And then it was just in time when DJI deployed the Dock 2, where it was possible to put in the LTE dongle, so that we were able to connect directly via LTE, and now be able to also fly the inspections at a lower level. So it was really more or less just in time. Yeah, and now we are looking for, so the next site where we have the new dock is the Dock 3, and then we will also test if there's even more benefit if you're having this technology on field. Yeah. And in parallel, yeah, there's always the hardware side. So we are at the moment, as I think 98% of the people focusing on DJI equipment, but there's also the software side. That's why we are in discussion with you, but also with other software suppliers, checking which solution is the best for our company. And there we are not just looking into one case. We have a lot of cases within the company group, and the software in best case can cover more or less all of them. Yeah, that's the aim, and that's why it makes it a little bit more difficult. Yeah, if you would be just looking at one specific use case, I think it's much easier. But if you say, okay, I just want to have one software more or less for all the docks to be deployed, nevertheless, if it's PV or is it a gas power plant or coal power plant, or for, don't know, substations for the grid provider, then it's a little bit more to be taking into account. Yeah.
I think, Timo, you covered a lot of the specifics and actually coming on to the main point as well, how to actually maximize the ROI. I think that's the real key. And indeed, as of today, DJI makes one of the best hardware. More than 98% of the automated, you can say, drone ecosystem is dominated by DJI. So that's regarding the hardware part. One thing I was again very curious to figure it out that let's say you mentioned regarding bringing in all of those operators which were earlier, I think, through some consultant. Now you are getting all of those projects inside your company. So being such a large company, especially handling so many different, you can say, different ways of energy generation. So, if you can just probe in on the specific constraints that actually shaped up, like, or pushed you through, or gave you the confidence of going ahead with such a deployment. So, I have certain pointers, maybe you can comment on this. So, was it mostly for IT and security reasons? Which, let's say, have shaped up your deployment so far? Or is it bringing in the operators from the consultant towards your internal company? That is the key thing that you wanted to do, and that is why you are using dog drones. Or let's say, handling all of this multiple sites all together, and easy, you can say, orchestration, because of course with the manual drone it's very difficult to train, and with the software based automated way it's very easy to train the pilots. You get actionable insights. Or is it cloud on-prem? I know there are a lot of pointers, but what was the actual thing which pushed you, let's say,
Mm.
or is something that you are trying to consider if you are bringing this to every other site for EMBW?
Yeah. So I think this really depends on the site itself, if it's within the critical infrastructure or is it not. In some cases, it's difficult to bring in a drone dog as a camera or even a yeah, physical movable hardware into such a system where the critis is responsible for. So that's why we, in first instance, decided for the POC to implement the dock not within the internal network we have, because then we had to do all the regulation stuff to implement the hardware and the software into the critis and so on. So at the moment, it's just separated. It's physically, it's on the site, but it has an extra LTE connection and so on, that we are for testing a little bit faster. In the future, we have to check if we will go for on-prem or if it will keep like it is. This is nothing I can answer, and I think at the end it's a decision from our IT security and cybersecurity, especially how to handle this topic. We have an internal drone community because of all these use cases and all these users. So we have a few hundred drones already in operation in the company, and to manage everything here, it was necessary to align and check, okay, which softwares are already in the company. Can we maybe use it together and save some money, or also discuss the topics of security, of do we need a firewall for specific parts where to store all the pictures and so on. So this is still an ongoing process, and I cannot answer completely. But these are all points to be mentioned if you want to implement something like a drone dog, or is also non-dock drones. I think you have to think about, because at the end you always have connection to internet. The data can go somewhere where you probably don't want to have it, and so cybersecurity is a really high topic which has to be discussed. At the moment, if you have the point where you say, okay, we keep it like it is, but the cybersecurity department is really checking this in detail, and could be that we maybe have to go on-prem, or maybe also for the non-dock drones to have extra software for the controlling and so on. This is an open topic, but I'm no expert for cybersecurity, but this can be mentioned. This, I think, the major point.
I think, Timo, that's something which everybody fears, getting instructed by the cybersecurity team to do this or do that. Of course, as of the POC stage, it's a very logical choice to stick with, let's say, a cloud-based solution or having access to everything. But indeed, finally, you need to take into the consideration of on-prem either or some other kind of deployment, having a firewall into place, etc. So, Timo, coming over to the next stage. So let's say you started with manual way of inspection, too much data, haphazard way of generating reports, to a drone, a bit of standardization. Still, the data is again so much that you are not able to orchestrate it properly. To now having a tool, let's consider it as a very good tool for capturing all of your images proactively, or at least giving you that data automatically in a less amount of time. How are you handling these of this amounts of data now? Like, what are you doing? Maybe there are certain questions also around this, but I would love to know more from you.
Yeah. So as I said, this was one part was the hardware part. So deciding for drones where you probably cannot uh, go away from DJI drones at the moment. Also for handling the drones like Flipbase or Flight Hub and all the other softwares. But for data evaluation, we also did a market research 3 years ago, and I really checked a lot of softwares which are handling this, PV drone data and evaluating and so on. We decided at the end for the SiteMark solution. Is a European company, and we are pretty happy handling with them because the team is great. We're always discussing more and more, let's say, functionalities. There are probably tools on field which have more functionality to offer, but we said, okay, it's a European company. This was one point, and the other one was user experience and also user interface is a major point. I would say you have to consider if you want to implement it into not just for a smaller group of engineers. You also maybe want to share data with the maintenance teams, with don't know some management guys which have no idea about technique at least, or if you want to yeah just inform some stakeholders and so on. And the training time I have to spend to learn people, okay, this is the information we got by drone images, and here you can see these are the tickets I have created, and you have to take care for this and that, and this is a module you have to take care for, and this is a string you have to take care for, and so on. Everything was is super easy to handle there, and I think this makes my life easier, and at the end also the life of the maintenance teams which I'm training to use it easier, because it's really easy to handle. Yeah, and tools with too many functionality, normally also have a lot of buttons, and too many buttons sometimes for someone who is new into the topic makes it difficult to handle it. And so, that's why we said, okay, this is a good approach, and we are super happy at the moment. And also the feedback from the on-field teams is pretty good. Yeah.
That's great to know, Timo. I was actually again curious on knowing how exactly are you able to get now actionable insights from, let's say, pulling in this data into SiteMark, and are you using that data daily? Of course, for solar PV inspections, you have these inspections scheduled, and you know what day, what time, let's say at least a specific duration when you have to do this inspections for a particular site.
Mhm.
So what are the exact like now outcomes? And of course, you can compare it to previous outcomes also versus the outcomes that you are getting now. Are the inspections better, more accurate, and finally, the job cards, let's say if you make it for the maintenance team, how have those shaped up now for the
Mhm.
dog drone? Maybe some
Mhm.
insights from your POC that you have done up.
So in comparison to the consultant part we had far before the doc or the drones came into our company, um, there are pros and cons for sure. So the benefit is we now get all the failures on field tracked by the software. The AI of SiteMark is checking all the images, and you will get every single failure down to a very low delta temperature tracked, for example. This is something which the consultant companies never did. They always have a limit of, okay, you will get, I don't know, 200 of the major failures will be tracked, and everything else you have to pay again for more, because they had to manually type it down or put it into the PDF and Excel sheets. And this is, this was no way we wanted to work, because we want to know everything about our site. And that's why this is an improvement, definitely. The con is more for sure a consultant which is really going on field, which is an electrician, which is someone he is trained to look at a module, has probably a much deeper insight into the failures which could happen, and can go more into detail than just a image, a visual and thermal image can give information from 25 meters height. That's the difference. We still let, by commissioning a consultant company working through our site, also partially checking modules, but we also do the overall inspection by site mark. So for commissioning, it's always in parallel, let's say. And then afterwards, it's let's say my turn and also the turn of the inspection teams to compare both. So still we have the full inspection by drone from 25 meters height, but also guys walking through have experience in detecting issues which you probably cannot see with 3 centimeter GSD thermal or 1 centimeter in visual image. Yeah.
Mm-hmm.
So,
Thibaut, you mentioned about the altitude and certain GSD parameters as well. It would be really wonderful if you can get into the detail of how your usual mission looks like. Like, do you schedule it first of all, or it's a manual, you can say triggered? It could be that. And getting into the details, oblique mission, what are the specific GSD parameters that you usually consider for better insights from SiteMark? Anything that you have observed that is working out for you, it would be really great to know about this.
So just a normal inspection. So if I go on site or want to go on site, I normally do what every drone pilot probably have to do. He has to check the regulations at this site to a specific time, make the checks. Is there, don't know, airplane or a flight, an airport nearby, or if it's a hospital with a helicopter landing place or whatever, and then you have to get the permissions for doing the inspections. Luckily, most of the PV sites are in regions where more or less nothing is, so it's a little bit easier. Then you have to check weather conditions. You have to check also is the curtailment at the moment. So historically at this time there, so especially grid curtailment, or is it windy? Because not just the wind wind is taking care in case of too much wind will reduce the accuracy of thermography, but also if we have too much wind, then also the wind turbines nearby normally are running, and then the situation is that if both is running full solar and wind, you normally get really fast curtailed by the grid provider. So you also have to check that. And if you're then ready, you go on site, you make your normal checklist, checking the drone and so on, and perform the flight. It's normally pre-programmed. I do it the day before or at home, let's say, programming at the controller, or already have it programmed, and then just start the mission. So this is normally an automated one, and at the end you're just taking the data and put it on SiteMark. Yeah, that's it. And then the process is done on the SiteMark side, and at the end you just get the finalized results, and you can handle then, okay, you got the anomalies, and then you have to say, okay, this anomaly is relevant and that one not. And so I will place the tickets and discuss with the operation managers, and then we send the information to the maintenance guys and say, okay, now we have tickets created due to the terminal inspection, and yeah, please take care. So then normally they make whatever they do, changing modules, inspecting if the hotspot is really there, if the bypass diode is really broken, or if it's just an artifact of the measurement, and so on. So that's the normal process. And yeah, I think this will not change a lot from the one with a dock drone. The only thing is you save the driving time and you're much more flexible regarding curtailment and weather conditions. Yeah.
Any specific limitations, Timo, also that you have observed? Could be, let's say, a particular functionality that you foresee, let's say, or is everything well off included now into whatever operations you do? Now, let's say manual operation, a pilot, now automated one. So, is the automated one actually improving your usual way of inspection, doing much better, giving you everything, all the insights that you get
Okay,
in
yeah.
a very
So in case of quality, you mean of the images, or yeah. So at the end, the hardware, if you have a M4TD or MF4T, which you are flying, it's more or less the same. You probably perform the flight always on the more or less same height or the same GSD. So we are always focusing for a normal inspection for the 3 centimeter thermal. And it's also possible to get to, let's say, higher GSDs doing the same inspection, but there's a ISC norm which says, okay, if you do a thermal inspection for PV modules, you have to do the 3 centimeter thermal. If not, it could be that if you make a claim with the module manufacturer that he says, okay, no, it was not like ISC says, so I don't accept, and then you have to do the flight again. So that's why we are always going on the safe side and make the 3 centimeter, but you probably get also string or bypass diode fails, or also really hot spots with a higher GSD, and maybe also with a lower irradiation, because you normally also need the 600 watt per square meter irradiance to do a proper inspection. So that's why we are making a mixture sometimes. So we sometimes say, okay, 1 year we do a 3 centimeter inspection, and the next year we make just a more rough inspection because the site in general is in good condition, and then we can save some money and some time for inspecting, because the lower GSD will result always in much higher flight time and more data to be analyzed. And we also have done inspections with much lower GSD, especially for detecting glass breakages, for example, like ultra high definition inspections, because it was not possible for our maintenance teams to track all the cracks, especially in the higher rows of the module table, by eye, because they're sometimes really small and you have a bad angle for viewing if you're at the ground. And that's why the drone is pretty good, but then you have to go really, really low. And so we had inspections with less than 0.1 centimeter GSD. So really very detailed ones. Yeah.
perfect, Tim. I think you actually covered a very important point wherein, of course, we are also like, I think every enterprise who is doing solar panel inspection is having a problem with the total number of images captured. I think the total data is too much, and of course it takes a lot of time for processing. So specifying a certain GSD which will work and of course optimize the whole operation. So of course it's two things, like time versus the kind of precision that you want. So that's somewhere you have to work around. So I just was very curious as well, like what is your turnaround time? Let's say you did your operation at, like, let's say now your time zone. What is the earliest possible time till you get all the processed, you can say, report finally from the post processing software out? So has that time also reduced now officially, or is it something that you're still trying to optimize through the mission programming or through some customizations on the post processing layer?
Um, so I think speed is not that relevant in our utility scale level. So we normally have a lot of work to do. The maintenance teams have a lot of work to do. There are a lot of tickets, and if we get new anomalies and new tickets, it's just put it on the list and maybe prioritized if there are bigger issues, but normally they just step by step working the tickets and correcting the issues. So it doesn't matter if you get the inspection done within 1 week or 1 day or maybe live, or if it's just within the next 3 weeks where you get the data evaluated. In some cases, it makes sense that if you're on site, but then the pilot has to be able to interact. So it has to be the electrician, the maintenance guy. That's why we are training them. That you say, okay, if the maintenance guy is doing the flight and he sees, okay, there are, don't know, 5 strings in open circuit, he can mark it directly on the controller and go and check it and correct it. Maybe the fuse is broken or connector is not plugged well or whatever, and then he directly can fix it, and he don't have to come again for this failure. And yeah, that this makes it a little bit more efficient, maybe, but for let's the sum of failures, it's much easier to make it afterwards, because afterwards I have it on a platform. I'm able to filter. I have to check more in detail. Is it really a failure or is it just an artifact or so? And yeah, so in my opinion, it doesn't matter if you're fast or not fast. So it's more a matter of quality, what you get. This is important, that you don't have too much anomalies tagged, which are probably no anomalies, which are just some artifacts, or also positioning of the failures are accurate and so on. Yeah, I think this is much more worth it to take time and get accurate data, because if the failure is maybe at a module beneath, then guy is going there, maybe you cannot see it visually, it's a thermal one, and you will try to measure module, and then he says, okay, everything is fine, and the next inspection shows again the same failure but one module beneath. So yeah, that should not happen, but normally I don't think it happens. So we have not experienced that. Yeah.
Mhm. So, talking about scale actually now, Timo. So now you had one dock, one more additional dock you are adding. Of course, you have a lot of non-dock drones as well. So, what is the ideal scale now, let's say, from the context of EnBW? Is it more sites, more operators, or let's say different like or more asset types over time? Like, if you would just like to like just clear this out, how does the overall scale now look like for EN?
A scale in case of drones in general, or in dock drones. So there are two parts. I think the handheld drones, non-dock drones, it's constantly scaling. In case of number of hardware, this is a little bit slower, but number of pilots is scaling a lot here. So we have our own training program with 5 days of training, doing the European A1, A3, doing the A2 certificate, making an internal training for how managing all the regulatory stuff. How do I get the confirmation from the no airport and so on to do a flight? Then we have training for photo inspection, so that people know. So you're taking images, but it's a camera which is moving. So you have to know about blurring, you have to know about focus and so on. So there's a training for, and then we have also a training for on field test, where we do a little bit of training for thermography, doing that people know, okay, what do I see there? Isn't it just the image, colored image? I see a temperature, but it depends on the scaling and so on. And then we also go on site and make a training on field on a PV site, and then they can see, okay, this is a string in open circuit and so on. So this is something we implemented within the last also 2 years on in the company. It's a large company. We have our own training center, which makes it easy. But this is a type of scaling we are doing. Another scaling for the dock drones is, it's, let's say, open. There are a lot of discussions internally regarding using dock drones for surveillance or parameter detection, for conventionals, for PV sites, for inspection of substations, and so on. So there are a lot of discussions. That's why we have this internal drone community to discuss these topics and share all knowledges. And so the PV loss flights at the moment, PV, because it's one of the easiest ones, it's always far away from everything. You don't need a difficult SORA to get a permission and so on. So that's why we decided, okay, we try it on a PV side. Also from inspectional side, it's easy to deploy it. You have a lot of space there, and not so much people walking around. And that's why the POC is running on PV side. But if we have a positive feedback from that, I think the scaling into the other use cases will be coming within the next few years or months.
That's interesting, Timo, and I think that's how the whole ROI game will also kick in. Wherein, let's say, there is a possibility of deploying these units across all different verticals. You will be able to give even more actionable insights to your higher management, and they will be also able to realize the overall value of such solutions. So, coming over to certain questions that we have got in the Q&A tab, Timo. So there is a question wherein Klaus has asked, like, can you explain the whole process for condition-based maintenance, and what are the steps involved from inspection to the maintenance action? What data inputs are needed to generate a report, and is this report AI based?
So for the drone inspection, you just need the drone. You have to program your route path. Yeah, there's a definition. It depends. I can also talk for others, but I just talk about the site-mark process now. But it's the same for all the others, Raptor maps and side view, and there are a lot of softwares around. You can check by your own, and everyone has another requirement, how which overlap you have to fly, which angle the camera has to be set up. But in general, you're just saying, okay, this is my defined area, and you have to define the parameters as the software provider requires. In our case, it's normally 70% overlap in the front, 30% overlap on the side, and nadir 90% angle of the camera. And then you're just doing the inspection as the drone is providing the whole mission. So you just have to program it and then say play, and you get the data and put it on the drive of SiteMark. And so this is super easy. And then for sure, that's on the SiteMark side or on the software side. It's not only SiteMark, you can also use another one, but you will probably get after a few days or weeks, depending on the number of images and the size of the site, you will get a report with the anomalies, and then you can check by yourself. You can see the different types of anomalies, the causes. They always make a combination of visual and thermal images. So if you have a hotspot, then they check is there shadow due to vegetation, and then they directly tag, okay, it's a hotspot, but due to vegetation, and then you can just say, okay, ignore because I just have to do grass cutting, and then the hotspot is gone. But maybe there are other hotspots which are not used to such a topic, and then you can filter it and so on. So I think that's a normal process, and I hope I understood the question correctly to be answered. If not, always feel free to contact me by LinkedIn also. Then we can have to discuss it in more detail.
Perfect, Timo. I think we can move on to the next question. So, as a follow-up, I think this could be a question. What part of inspection workflow still requires the most human judgment as of today?
So I would say especially, yeah, so drone at the moment, so I've tried it. I'm still trying it, but inspection with the drone of the rear side of the modules is super difficult to manage, especially due to the angle of view. Even if you fly at 1 meter height between the rows and have a look beneath the modules, you will not see everything. So I think there you probably have to do a lot of human interaction to see. So I'm just speaking about PV modules, not speaking about inverters, combiner boxes. So this is another topic. There you definitely need human interaction, because you have to open a combiner box or a central inverter and check something inside. If there's a hotspot, if a fuse is broken, this no drone can, or even if you have a ground-based robot can manage. Yeah, so not at the moment. Maybe in the future, if you have humanoid robots, then they can maybe manage it. But yeah, this is a manual workflow, definitely. So rear side is something which is open. From the front side, you probably just have to go a little bit lower with the drone, then you get better images. And then probably the AI or also the guys which are normally managing to make the post-processing of the AI. It's not just AI based normally. There people are checking if the AI has done correctly, and then you get your anomalies and your report. So it's not only AI based, but they can just see what your camera resolution provides. So I think that's the limit.
Cool. There's another question from Angela's, and the question is, usually when we start a project, we had certain expectations, but what was above your expectations? Like, did you observe some kind of a higher performance or efficiency or something that you would like to figure out on the basis of your feedback?
Yes. So for sure, with the drones, at the moment, we are just comparing manual drone flights with the docked drones, for example. And they are just on a economical future. Just one flight per year of manual with one flight per year with the docked drones. I also have done calculations regarding, okay, if I make half yearly, quarterly, or even more often inspections with the docked drones, do we get the benefit of that? And that's why we are doing this POC. So that's why we have the two docks placed and do now these more frequently inspections and see if we have a benefit. But this really always depends on the quality of the site, on the failures. So if you have the perfect site with no failures, you will never detect a lot of failures on site, anomalies, and then the benefit is low. But it's a little bit like condition monitoring is like an insurance. You pay for it, and if you need it, then you have the information. That's the way it works. So that's why we just try to compare one flight per year with one flight, so manual with the automated one, and said, okay, if this is more or less price even, then we everything we can get more is just a plus, and that's what we are working at the moment. And at the moment, yeah, it's really like that. So depending on the size of the site, yeah, this is a limit which we are still aiming for, which is the right one. So to set, so is it, I don't know, 20, 50, 70 megawatts, where we say, okay, for this size site of PV sites, it's worth it to place some a drone dog for the PV inspection. Yeah, to be defined, I would say.
Just to follow up on this, Timo, has the ROI justification already kicked in as per?
Um, to be honest, we had no full year of inspections done with these more quarterly inspections due to, don't know, hardware, software issues at the moment. So that's always what you have with a POC. There are always some issues at the beginning. That's why I cannot tell if the return of invest is there. But as I said, it's at the moment with the calculations, all the capex and opex we have for a drone dog placed on site, in comparison to I just book an external pilot, and he will cost me, don't know, X 100 euros. If I take this into account, then I would say yes, it's already kicked in, because yeah, we are much more flexible now. Yeah, especially if I have to say, okay, if I send the external pilot there and I have the curtailment, and he just has to get one day there where curtailment is, and I have to pay for him. Yeah, it's one day he has spent, but I don't get any result, and he has to come again. Then you already have a benefit of it. Yeah.
The last question, Timo. We are running out of time. How about BV laws? It's been very difficult, right, to get approvals. How did you do it in the first place?
Yes, to be honest, at the moment, we are still in the POC level. We sent our yeah, permission request to the Behörde, to the government, and they said, yeah, we will take care. Please wait, and we are still waiting. So at the moment, we are not able to do BV loss due to too many requests for the government, and they are not able to check and approve it. So at the moment, all the tests we are doing, we are making with the software, but sitting on site. So the return of invest is more or less calculated. I still waiting for the BV loss permission. I assume that we will get it within the next months, but yeah, you never know. Yeah, but I think this calculation can be done if I say, okay, I don't have to spend 3 hours driving in one direction. Then it's clear that the ROI is there. So yeah, at the moment it's a little bit stressy doing the tests, which makes it difficult. That's why we are not able to make these yeah, full ROI calculation till now, but yeah, I hope this year will be better. Yeah.
I think that's the end of all the questions, Timo. So thank you so much, Timo, first of all, for walking us through what looks like in reality, not of course in a polished end state, but a real system, real constraints, and real learnings which everyone in this industry is now trying to solve. And of course, you have presented your thoughts on how you will be progressing with this POC. How did you convince your internal team about all of the constraints that you have faced? And yeah, at the end, of course, this is something which every other industry person will also relate with. So in the like, of course, you can also ask if you have any of your questions, please feel free to drop in. We can answer those out on the email. But yep, really appreciate Timo for you taking out your time and other people as well who have joined in. So yep, thank you so much, guys. And let's catch up on another session which we usually conduct every week. But yep, anything else, Timo, that you would like to share as a closing thought for the
No, thank you for the audience, for all the questions, and for listening. It would be a pleasure if we get connected by LinkedIn or by email. If you have any questions more in detail, feel free. Yeah, I'm open to discuss everything. Yeah.
just the last ending question, Timo. If
Yeah.
any other energy company is watching this webinar, and what is the one thing that they should do right before choosing? Just in one word, if you say.
Um, Take care about the lock-in effect of software. Yeah, if you decide for one, then you're locked in, and it's always difficult to be more flexible. That's why take time for choosing the right one.
I think that's a great answer, Timo. But thank you so much, guys, for your time and have a great day.
Bye bye.